This problem says the model for a transresistance amplifier uses a Thevein's equivalent circuit at its output. Is this true or false? Well, when we look at the four types of amplifiers that can be found linked below the like button, the notes, we can see that for a transresistance, we have our gain equal to the voltage output over our current input. Now this makes sense if we do transresistance. And transconductance is just the opposite, where it's I out over V input. You can always think that the outputs are on the left of this division and then the inputs are on the right. But anyways, back to the transresistance, we have a V out over I input. And when we have voltage output, we know we're going to be working with Thevein. So the use of Thevein's model for the V output, we would use Thevein's equivalent, and that's because with Thevein's, the basic general form is that we have something like this. We have some resistance right here, or some source resistance, the total resistance, and then we have our nodes here, like this, and we have our voltage right here. And so that is going to give us voltage output. For Norton, which is not what this is, Norton would be used for like the transconductance, where we have the I output, or the current amp. That's where we have current flowing through. We have this resistor, and then we have our terminals right here. And so this is how we would solve this problem, looking at this one, the Thevein's equivalent for our transresistant amplifier.